I hope everyone who wanted to listen something else besides Paul is here and is ready to listen for my rather not interesting talk. So I will try to squeeze it in 5 minutes I was allowed. So I guess it begins right now. So I fear this might sound a bit heretic after all we heard today. But actually, considering some things you said, answering to Mitya's question about languages, I suppose this might be interesting to you personally, Paul. So, a little bit about me. My name is Maxim. I'm 23 years old, and I started programming in like Pascal by reading old books and experimenting with it. So I came to Python through C, so I moved from Pascal to C, then to Python, and Python was never a first language for me. I guess this is not the case for most of you here. And at some point, I discovered functional programming, and for some reason I can't explain, I loved it. But this talk, despite its name, will not be about functional programming as it is. You can think about like functions, composing, higher order functions, all this stuff. But I will talk not about it. About what will I talk? Actually, I'd like to talk about types. There is this book, Types in Programming Languages by Benjamin Pierce, and it gives an definition of what is a type system. I will read the English version. A type system is a tractable syntactic method for proving the absence of certain program behaviors by classifying phrases according to the kinds of values they compute. The important thing to note here is proving the absence of certain behaviors. Read errors. And so, there are some different types of type system, kinds of type system. And I could not include this picture here. What is, in simple words, static versus dynamic typing? Static typing means that you must specify the type of something at the point when this thing is defined. So, for example, imagine that Python threw a syntax error when you defined a string variable and tried to assign an int to it. Think about it, not runtime error, but syntax error. That would still be interpreted language, but it will have a static typing system. And strong versus weak means that strong type systems do not allow implicit type conversions between different things, and weak systems, well, they do. These words are a bit debated, so there are no like precise definitions for them. And important thing to note is that dynamic system is essentially a system where there's only one type, like a type. And everything else is just runtime text. What about this? Python is, of course, a strong but dynamic type system, quack. There are stronger type systems that you can imagine. There are like systems with polymorphisms like in Haskell, which we will see soon. There are like things, scary things like dependent types, linear types, and it's very nice to know that these academic things like linear types is somewhat like what is implemented in Rust. But why? Why would we want all of this? Sorry. I will be a Captain Obvious here. You can get rid of a lot of kinds of errors when you have types in your program. So it gives you guarantees. And if compiler checks your code, why do you need linter at all when you have compiler? So you have like full code coverage for a huge amount of kinds of errors because you are compiling. And stronger type systems give you stronger tools to model your domain. So in Haskell, for example, you are welcome to define your data types, like a shitload of data types that are actually like bool, or like this text here, text string here. I defined like a couple of days ago when working on something. So I wanted to represent an account widget that can hold just one account or multiple of accounts. And I defined a type for that, and I can be sure that I will never screw something because I always be referring to the correct type. Yeah, and speaking about Haskell, it gives you a compilation to native code and a powerful runtime systems that has like something like green threads or Go routines, but is actually very safe, and if you think about it, it's very like easy to use. But you still have to write unit tests, of course. You still have to write integration tests, and quick prototyping may be a pain because like your type system wants you to write types, but you are not sure yet what the types are, so you're like screwing with the type system just to let it run your prototype. Yeah. So and here's this funny thing. Python and like other mainstream languages are adopting some of these things. And when looking for an example of data classes, I found this so funny quote in the PEP for data classes. Like any named tuple can be accidentally compared to any other named tuple with the same number of fields. And this word accidentally made me laugh for so long. Yeah. And they had to invent a whole new thing, like whole data classes, to prevent this. So it took like 20 years of Python to realize that that is a problem, actually. And in a strongly typed, statically typed language, you almost never will hit an error like that. And to give an example, I encourage everyone who writes in Python to start using data classes everywhere to define like ad hoc data types for things they send between functions in their programs. Stop using tuples. Named tuples are not good, and unnamed tuples are pure evil. I fixed a stupid bug today because I was foolish enough to use a simple tuple, and I thought I will always remember what this field is, and of course I did not. And for comparison, there is the same record defined in the Haskell syntax, and we do this like every time. I will create new model, define some types, and then write functions to change them, to operate on them. So, and here's a little bit about where it's used in production. So, a real message of my talk is to make some of you interested and maybe wanna try. So, here's some places where it shines, really. I'm working at Circle. We are making cryptocurrencies, so I'm gonna mention blockchain first. I'm not very big fan, but still. Practically everything where you want proofs and correctness will lead you to strongly typed languages, and I hope Haskell. So blockchain, everything related to formal verifications and adding guarantees to conventional languages. I mean this. There's a thing called inline R. It's an R interpreter embedded in Haskell. It was created because some pharmaceutical company was writing a lot of R and they screwed up. So they hired a French Haskell firm to write for them an R interpreter embedded in Haskell. So their R specialists can write like small snippets of code, stick them into a good written Haskell program, and it will run. So this is actually created by this company on the lower left, Twig.io. They are represented by one person in Saint Petersburg. Bioinformatics. There is this company, BioCat, with their engineering department right here in Saint Petersburg, and they are hiring Haskell programmers, and they are hiring bioinformatics people, and actually in a couple of weeks I'm switching from Circle to BioCat, and I still be doing Haskell, but I will still be coming to Python meetups, of course. And yeah, quite funny, but some time ago there was a job offering posted on Reddit in Tesla. They are doing data processing in Haskell. Yeah, and Mitya, I hope will forgive me for this last slide. First of all, this is a thing we are developing, a cryptocurrency wallet for Cardano. Yes, this is your laptop. It is written entirely in Haskell. It is native desktop application in Qt, and I hope you will agree that it looks like good. It's not an Electron app. It's like native app, and I wrote like most part of the UI. So we hire Haskell, of course. We hire DevOps engineers, and like front-end people can try to apply because we really need front-end people right now. Yeah. If there are any questions, I will love to answer them like at the after party right now. Like this depends on me actually. Okay.
Just a sec. I have a small question. What if I want to write in functional language in production, but I also don't hate money? So should I took Haskell still, or no? It's just a curiosity.
Well, let me try first. If you are really a good Haskell or like any other functional language expert, you will get, of course, a big salary because there are not so much of them. But if you just want to start in the industry, I believe the easiest thing to do is to go with like something like Clojure script for front-end development. Clojure is like Lisp that is transpiled to JavaScript, of course, and it's a really strong community as far as I know, and it's not so academic at Haskell. I believe many of them like hate us or something like that. You wanted to add something?
Well, if you don't hate money, you can like go to London and work at Bloomberg. They have like a team of, they have a, I think, largest team of Haskell developers right now. They also love Python, but well, not in London. Anyway, so my small question. Like I dabbled in Haskell like maybe 3 or 4 years ago. It was a very long time. And there was like a saying then, like a cabal hell, you know, for package management. I know that package management is not easy in any languages. I think like we have a couple of talks about like, is it still bad?
Depends on who you ask. For a newcomer, for everyday programmer, it is good. But the tool that came to solve all our problems is a bad design-wise. So like the academics don't like this tool, and they are working on improvement. But while they did not produce a good tool by their judgment, we have to use this tool, and well, it works. And it works, I'd say it works good. I use it every day for building my package, so no problem with that. And this one point I forgot to say. Probably in PiterPy Meetup in November, I want to give a tutorial on using types in Python. And I will take this like 2 months to prepare. I will hope it will be enjoyable and useful. So please come and hear it.